Hello, my name is Adriana, and today we are going to start with population and sample definition. Population is a set of items that belong to the study subject. Some examples of the population will be the following. Spain population, 47.5 million. ES colonial student. English language speaker. Within the population we have the individuals. They can be defined as each of items that are included in the population. Following the previous example, we will have each one of the Spaniards, each student of the colonial ES, every person in the world who speaks English. Nevertheless, population is usually a big universe which may be very difficult to work with it. Because of this sample is usually extracted, which is the subset of item previously extracted, and it is able to infer characteristics of the entire population. According to the example we have given before, when we take a sample of them, it will be as follows. Unemployed people, 4th ESO student, C1 holder. The variable of statistical variable is one that goes through all the data values of a certain character. They are divided into several types. Quantitative, it takes numerical value, for example, number of people who live in a state or number of people who work as teachers. It has two different categories. Discrete, it can only take certain value. Following the previous example, people who live in a town or a state. Continuous, it can take any value in a range. In this case, the speed at which a train goes, the diameter of a sphere will be included. Qualitative, take non-numerical value, for example, head color or eye color, are qualitative variable. Next, I will offer some exercise to practice. Exercise 1. To study which presidential candidate the Spaniard will vote for in the next election. A sample of the 8,500 people is taken from all over the country. The question is, who will you vote for in the next presidential election? Find population, sample, and individuals. Exercise 2. A statistic student wants to know if the colonial ES professor preferred to teach classes with normal cloth or with informal cloth. That is why she conducted a survey of 30 randomly chosen ES colonial professors. Find the population, sample, and individuals. Exercise 3. Indicate which variables are qualitative and which are quantitative. A. The amount of money a teacher makes. B. Your friend's phone number. C. The degree he studied. D. The newspaper you read most often. E. The time you have been at work. Now you can pause the video and do the exercise quietly. To end, thanks for your attention.
bar graph, frequency polygon. Histogram, frequency polygon. And diagram of sector. Bar graph, frequency polygon. It is used to represent quantitative or qualitative data. On the x-axis we put the variable value and we raise bars with the same height as the frequency represented, and they could be absolute, absolute accumulated, relative, and relative accumulated. Frequency polygon. It is a polygon line obtained drawing in the bar graph. A line from one point of a bar to another point in the next bar. The tree diagram. The tree diagram is an optimal producer for making or simply counting ordered sets. This is the structure of a tree diagram. With the tree diagram, you can think step by step, and it allows you to see what are the different possibilities that occur in each of these steps. If instead of listening all the possibilities, we just want to count, then we can leave the tree diagram incomplete or even just imagine it. Now I do an example. The Spanish Copa del Rey football semifinals away games are due to take place. The teams are Mallorca against Deportivo and Betis against Albacete. How many Betis do you need to place in order to be sure of winning? The solution is 9 bets.
Now I'm going to explain you the statistical graphs. They are the bar graph, the histogram, and diagram of sectors. The first we need for all graphs are the table of values. I will take these values for all graphs. The bar graph is easy. When you have the values, you must do the lines of the graph. This is the y-axis, and this is the x-axis. Now we put the values in the graph. In the x-axis, we will put these values, and in the y-axis, we will put these values. do the bars. And the result is this graph. The histogram is like the bar graph, but we don't use bars. We use dots. You connect the points, the marks with a dot. Very important, we mustn't connect the dots, because if we connect the dots, it isn't a histogram. For example, this is a histogram because the dots isn't connected, but this isn't a histogram because the dots are connected. For the grammar of sectors, we take other values. For example, I have a school with 100 pupils. "50 pupils are in the third year. 10 pupils are in the second year. 40 pupils are in the first year." So, in the third year are the pupils in the third year are the 50% of the pupils in the school. The pupils in the second year are the 10% of the pupils in the school, and the pupils in the first year are the 40% of the pupils in the school, and all the pupils are the 100%. A cycle are 360 grades, and if we want to represent all the pupils of the school in this cycle, we must do this step. Um, 360 grades of the cycle are all the pupils. 50 pupils are 50. The 50 are multiplied by 360, and the result of this operation are divided by 100. The result of this operation are 180. We must to have this operation for all all the years. This is the third year. Yeah. And these are the results of the all years. And we paint the circle and put the years with the grades. For example, third year are 180 grades, and the space it takes is of 180 grades.
Hi and welcome to my final task. I'm going to talk about Laplace law and tree diagram. Tree diagram is a graphical representation of the possible result of an experiment which consists on a series of steps where each of these has a finite number of ways of being carried out. It is used counting and probability problems. For the construction of a tree diagram, we will start putting a branch for each of the possibilities, accompanied by its probability. At the end of each partial branch is stored a node is forming which new branches start according to the possibilities of next step. A step in the node represents a possible end of experiment, final node. It's important to remember that the sum of probabilities of branches of each node must always be 1. In compound experiment is convenient to use the so-called diagram in tree to get a global idea of all of them. A tree diagram can represent it in various ways, either vertically or horizontally. This is an example of a tree diagram in which we can see the different ways of combination of eating an ice cream. Laplace law. If we perform a random experiment in which there are n elementary events and equally likely equiproblem, then A, if as an event, the probability of the event in occurring is number of favorable cases divided into number of possible cases. An example of probability with which can use Laplace law is to see what is the probability that we take in a card from a Spanish deck. Since there are 4 cards that have 7 camps, spades, clubs, and gold, the calculation is as follows. 4 divided into 40. So 0.1% is the probability we have to take a 7.
Hello, I am going to tell about the probability, the Laplace law and the tree diagram. When I thought about the Laplace law, if the random experiment is carried out using an guessing instrument, a carried die, a complete deck of cards taking a board from the bottom when the bar are the same size and weight. Laplace law come into pain. Let us go to it one again. If the sample space has n outcome and the experiment is used, and then they all have the same probability 1 n. If an event has k outcome, then its probability is k n. And now I have one problem Laplace law. In a depth of Sagar, find as and copas. One probability of grade is the possible cases is 14 and the favorable cases of ace is 4. Application law, the probability of drawing an acid is P as equal 4 divided by 14 is 1 divided in 10. Show probability of outing cap possible cases is 40 and favorite cases or glassy is 10. Application Laplace law, the probability of drawing a class is P capas equal 10 divided 14 equal 1 divided 4. Now I am going to talk about the tree diagram. A probability tree or tree diagram is a tool used to determine if in a phase the calculation of many options requires now the number of objects that are part of the sample space. This can be determined with the construction of a diagram of tree. The tree diagram is a graphical representation of the possible result of the experiment, which of being carried out. It uses in counting and probability problem. For the construction of the tree diagram, we will start by putting a branch for each of the possibilities accompanied by its probability of its probability. Each of these branches is now of the first generation. Now I am going to have one problem for tree diagram. A coin has its face, a cat and a door. The coin is twisted. Should I calculate the probability of each of the cases? And the solution is we are going to make the diagram for the experiment. We calculate the probability for each of the possible cases. When we move the right, we multiply.
How we can obtain the percentage? Okay, we can obtain it if we multiply the relative frequency by 100. Now I'm going to explain it with an example. Here we have an example and I'm going to explain it. Here we have the marks of the student. In this column we need to put only the marks in order. Then in this column you just need to count how many times each mark is repeated. Then you need to sum the all values, but this you need to do it at the end. Then in this column you just need to divide this value into 30. That is the total. To finish, you need to divide this value into 100. So this is going to give you the percentage, and you need to count all, and all it will give you 100. If you do the same with these values, it's gonna give you 100 too. My name is Lara and I'm going to talk about frequency tables. First of all, I'm going to explain absolute frequency. Then I'm going to explain relative frequency. And to finish, I'm going to explain how we can obtain percentage. What is an absolute frequency? An absolute frequency is the number of times each variable value is repeated. Also, the sum of absolute frequency
is the total data. And how we can represent it in the table? Like this. I'm going to explain relative frequency. So the relative frequency is the quotient between the absolute frequency and the total number of data. We always need to know that the relative frequency is a number between 0 and 1, and the sum always will be 1. Also, we can represent it in the table like this.
Hello, my name is Maria Victoria, and today I am going to talk about the frequency tables.
I am going to explain how our absolute frequency calculated, how our relative frequency calculated, how our percentage calculated. First of all, what is a frequency tables? Statistical tables are used to sort and study the data of a statistical variable. How our absolute frequency calculated? The absolute frequency of a dataset are the number of times each value of the xi variable is repeated in the total data. Absolute frequency are recognized as fi. Let's look at an example. Example: the grade obtained in a math exam by the 20 students of 4th B were. With this data, we will build the frequency tables. First, we put the variable. Second, count how many times the value of the variables is repeated. In the total, it has to give the total number of data studied. How are relative frequency calculated? Relative frequency is the quotient of the absolute frequency to the total number of data. Relative frequency are recognized as hi. The formula is: we already know that fi is the absolute frequency and m is the total number of data. Let's look at this in an example. Example: a die has been rolled 20 times, obtaining the following results. With this data, we will build the frequency tables. First, we put the variables. Second, we put the absolute frequency. And finally, calculate relative frequency. In the total, in the column of each A, it always has to give 1 or 1 approximated. How are percentage calculated? The percentage are calculated for this formula. The percentage are recognized for the symbology. Let's see an example. The weight of 20 infantile children chosen at chance is. With this data, we will build the frequency table. First, we put the variables. Second, we put the absolute frequency. Third, we put the relative frequency.
And finally, calculate percentage. Now I propose a problem to you and you have to solve it with what we have learned. The number of stars for hotel in a city is given by the following series. Make a table of frequency, calculating the absolute frequency, relative frequency, and percentage. Thanks for your attention.
Hello, my name is Marina and today I'm going to talk about statistical parameters. Statistical parameters. These are divided into 4 parts: mean, median, mode, and range. At first, I'm going to start explaining the mean, and I will give you examples. The mean is a measure of centralization as they reflect the trend of data by concentrating around certain values. This is represented by an X. This is calculated by adding all the data and dividing by the total number of data. Also, calculation can be greatly streamlined using the frequency tables. For example, first tip, add up all the data. 1 plus 3 plus 5 plus 9 plus 2 plus 12 plus 4 plus 5. And this is equal to 41. Second step, divide what we have obtained, 41, by the number of data that we have. In this case, we have age data. So, it is the solution. Secondly, I'm going to continue with the median and one example. The median of a dataset is the value such that increasingly ordered the data, half are smaller than it and the other half longer than it. It's represented by me. If the dataset is an odd number, the median is the central value increasingly placed data. The values are 1, 3, 5, 2, 9, 12, 4, and 5. So, order the data increasingly. 1, 2, 3, 4, 5, 5, 9, and 12. Second step. Consider whether the dataset is odd or even. In this case, it's even. So we take the two central numbers and perform the mean. So it's the solution. Then I'm going to continue with the mode. The mode of a dataset is the value of the variable, or the most repeated intervals. It's represented by mo. First step. Look at the repeated data and see which are the most commonly in this case 5. So it's the solution. And finally, I'm going to explain the range and I will give you one example. It is calculated as the difference between the largest value and the smallest value of the statistical variable. To find the range of each chart, we use this table. And it's the solution of this example. And it's all. Thanks for your attention. I hope you understand it. See you again. Bye.
Statistical graphs. Bar graph. A bar chart, also known as a bar chart or column chart, is a way to graphically represent a set of data or values, and is made up of rectangular bars of length proportional to the values represented. Histogram. A histogram is a graphical representation of a variable in the form of bars, where the surface of each bar is proportional to the frequency of the represented values. Diagram of sectors. They are used in those cases where it is interesting not only to show the number of times that a characteristic of attribute given in a tabular way, but rather graphically is such as a way that the proportion in which that characteristic appears with respect to the total can be better.
The statistical parameters are used to synthesize or summarize the information given by a table or by a graph.
The statistical parameters are used to synthesize or summarize the information given by a table or by a graph. Some statistical parameters are mean, median, mode, and range. First of all, to calculate these statistical parameters, we will need to make a frequency table. For this, we are going to put an example. 25 families in our urbanization have been asked about the number of cars they have. The data is collected in this table. Mean. The mean is defined as the characteristic value of the data series resulting from the sum of all the observations divided by the total number of data. To calculate it, multiply xi for fi. In the table, add all the results and divide the total by n. This is the formula to calculate it. Median. The median represents the value of the center position variable in an ordered dataset. It is denoted mi. To calculate it, we have to add a column with the name of f majuscule I, the accumulated absolute frequency.
It is the same frequency above, but, as its name suggests, accumulated. Accumulated is adding the previous data. To know if we have done well, the final number. When this is done, to find the median, we have. The median is the xi whose f majuscule I exceeds the number given in the previous division. In this case, will be 1, since 16 is the first number that exceeds 12.5. Mode. The mode is the value most frequently in one of the data distributions. To calculate the mode, we look at the column fi and we look for the largest number, whose corresponding xi will be the mode. In this case, the largest number in the fi column is 12, whose xi is 1, so the mode is half a car. Range. The range is the interval between the maximum value and the minimum value. It gives an idea of the dispersion of the data. The range is also called the amplitude or measured path, and it is denoted as R. It is calculated subtracting the largest value minus the smallest value in column xi.
Hello, my name is Nuria, and today I'm going to talk about variable, population, and sample. A statistical variable is any characteristic of the element of a population or a sample that can be studied. Statistical variable can be quantitative variable. They can be measured and expressed by number. They can be discrete or continuous. Discrete quantitative variable take a certain number of values. Continuous quantitative variable can take any value between two given values. The number of people who live at home takes on discrete quantitative value. Age, height, and weight all take or continuous quantitative value. Air color and the means of transport used to get to school assume qualitative value. Qualitative variables, they cannot be measured and are expressed through qualitative or description. Descriptive statistics present and analyzes some characteristics of the individual in a given group without coming to any conclusion with regard to a large group. Inferential statistics, on the other hand, take samples and attempt to use them to deduce characteristics for the entire population. Population and sample. The population is the entire set of elements about which we wish to learn and which shall serve as the object of our study. For example, a population can be the 15-18 students in a school. A sample is a subset of the population. A study of a subject provides information on the characteristics of the population as a whole. Continuing with the example above, a sample could be a relevant group of 50 students. Why do you use sample? 1. The population is exceedingly large. 2. The population is very difficult or impossible to control. And 3. The measurement process is destructive. Sample size. If the sample is too small, we will not be able to draw any worthwhile conclusion from it. The sample is to be chosen at. The process by making the sample is called sampling. Random sampling is when the individuals in the sample are chosen at random so that all individuals in the population have the same probability of being chosen. Random sampling is the only one that guarantees the reliability of the conclusion obtained. Conclusion to get from a sample. The wider the interval, the higher the level of confidence we will have. On the contrary, if you want to refine your forecast a lot by reducing the interval, you will lose confidence in what you say.
To start, we will talk about what statistics are. It is the branch of mathematics that studies variability, as well as the random process that generated following the laws of probability, and is in a chair of studying a certain characteristic in a population, collecting the data, organizing them in tables, representing them graphically, and analyzing them to draw conclusions from said population. The mean. It results in determining a certain series of operations with a set of numbers, and that, under certain conditions, can represent the entire set by itself. The statistical parameters are obtained from a table like the one that we will see next. 8 isolated date or date are grouped in intervals. Now come an explanatory video. To calculate the mean, we need a formula, sum of all date divided into total number of individuals. 425 divided into 30, that results in 14b, that the average. The next section is the median. In the statistical field, the median represents the value of the central position variable 50% in an average data set. It is denoted mean. The median can be found only the quantitative variables. Now come an explanatory video. In the event that in a table of frequencies you find yourself with a few values, an easy way to find the median is to rearrange all of them. Then choose the figure that is left and right of the other figures. It is usually in the center. When you have many values, it is not necessary to order them all and check which one is in the center, but in the accumulated frequency column. Take all your values and divide it into 2. With the formula n divided 2 indicates n is the total number of values that exists. If you divide 25 into it equal to 20.5. To find the median, it will be the value of x whose accumulated phi exceeds the value 20.5. For this reason, in the phi in the 1 day 16 be created that 20.5. For that reason, mi is equal 1 car. The mood is something that all people know how to do since we use it to calculate exam notes by adding the number of notes between the number of exams. But what is the mood? Mood is the value most frequently in one of date distribution. This would in form of a column when we find 2 moods, that is, 2 datas that have the same maximum absolute frequency. Its main properties are simple calculation, very clear interpretation, and it can be calculated for qualitative variables. Now come an explanatory video. The highest frequency phi is 8, corresponding to the value C equal 14.1. Thus the mode is 14.1. because it is the value that is most repeated in the table. The range is a numerical value that indicates the difference between the maximum and minimum value of a population statistical sample. The range is usually used to obtain the total dispersion. That is, if we have a sample with 2 observations, 10 and 100 euros, the range will be 90 euros. Now come an explanatory video. Using the formula given at the beginning, R equal maximum minus minimum. R is the range, maximum is the maximum value of the sample or population, minimum is the minimum value of the sample or statistical population, and X is the variable. R is equal 20 minus 1 is equal 19 points. According to the result, this rating have a great dispersion. My name is Rafael Rosa Medina and I hope you like it.
Hello, my name is Rocío and I'm going to explain a common topic in mathematics, that is the frequency tables. What is a frequency table? It is a table where the statistical data appear in order and distributed according to the number of times it is repeated in the sample. The different types of frequencies are represented in the table, arranged in columns. Types of frequencies. Absolute frequency. The absolute frequency of a data set is the number of times that each value of the variable xi is repeated in the total of the data, and it is represented as phi. The way to get the absolute frequency is by counting the times the data appears in the dataset. The sum of the absolute frequency corresponds to the total number of data represented by the letter n. Relative frequency. The relative frequency of a data is the number of times that data is repeated in relation to the total number of data. It is represented as hi. The relative frequency is always a number between 0 and 1. The sum of all the relative frequency of all the data in the sample equals 1. Percentage. If we multiply the relative frequency by 100, we get the percentage. The sum of all the percentage equals 100%. How to build a frequency table? In a discrete variable example, we have the mark obtained in an English exam by the 20 students of a class that have been thus. To make this table, we have to follow these steps. In the first column, xi, we put all the variables ordered from the smallest to the largest. In the second column, fi, we place the number of times that each value appears. In the third column, hi, we put the quotient between the absolute frequency and the total number of data, 20. And in the last column, we place the percentage, that is the result of multiply by 100 each value of the relative frequency. In a continuous variable example, the number of people who live in each one of the buildings of a street are thus, and with this data, we build a frequency table. The steps to follow are: in the first column interval, we put all the variables, number of inhabitants per building, ordered from the smallest to the largest. In the second column, we put the class midpoint of each interval. In the third column, fi, we put the number of times that each value appears. In the fourth column, we put the relative frequency hi, the quotient between the absolute frequency and the total number of data, 30, and in the last column the percentage, multiplying each value of the relative frequency hi by 100. I hope you learn a lot.
What is variable? Variable, that statistical variable, is a characteristic of quality of an individual what is prone to acquire different values. The values in turn are characterized by being measured. For example, a person's color hair, the test score, sex, or age are statistical variable. Discrete variable. A variable discrete is one of can only take a finite number of values between any two values of a characteristic. Example, the number of siblings of five friends, 2, 1, 0, 1, 3, and 2. Continuous variable. A continuous variable is one that can take an infinite number of values between any two values of a characteristic. Example, the age of five friends, for example, 1.73, 1.82, 86. What is population and sample? In statistics, a population is a set of beings, individual object, element, or event with characteristics. Often a sample is drawn from that population that is a representative subject. After performing a statistical analysis of the sample, the results are extrapolated to the rest of the population. Statistical inference. A statistical sample or sample is a subject of element of the statistical population. The best result for the statistical process would be to study to entire population, but this is generally impossible either because they involves a economic cost of or because it requires too much time.
Laplace's law. Laplace's law is very important because it allows us to calculate the probability of an event. Events have to be that all results have the same probability formula and rules. This is the formula that is used. Here are some properties of this rule. Hi, this is the formula used for the Laplace's law. I will explain how it is done with a very easy example. The statement: in a ballot box there are 3 red balls, 2 white balls, and 4 blue balls. If we attract a ball, find A. The probability of it being red. Let's call the events by their first letter. R will be equal to taking out red ball. W will be equal to taking out white ball, and B will be equal to taking out blue ball. Let's apply the Laplace's law. The probability of the ball coming out is red is 3 divided by 10 equal 0.3. The probability that the ball is not white, which will be the opposite of white, is. There are 2 out of 10 white, so the opposite will be 8 out of 10 equal 0.8. C. The probability of the ball being red or blue is event R or B. The probability is the sum of both probabilities equal 3 out of 10 plus 4 out of 10 equal 7 out of 10 equal 0.7. D. How to draw blue or white ball. The zeros probability. The probability of blue plus probability of white equal 2 out of 10 plus 4 out of 10 equal 6 out of 10 equal 0.6. The three diagrams is an easy graphical method, so that when it comes to making problems, you have all the possible result of the experiment. It is used in counting and probability problems. I will explain how to make a tree diagrams with a very easy example. Started. Here is the statement. Olivia has 4 scarves: red, blue, black, and green. Nacho has 3 hats: gray, orange, and white. How many different ways can you wear a hat and a scarf if you decided to share your clothes? Simple experiments are choosing a scarf and choosing a hat. We make a tree diagram to get us scarves red, scarf blue, scarf black, scarf green. 3 branches each. As we have already done the diagram, now to know the solution, we have to count how many combinations they can make. In this case, there are 12 sets of hat and scarf.
Good morning,
I am Susana and I'm going to speak about the tree diagram and Laplace's law. Well, if we want to calculate the probability of something, we use the tree diagram. For the construction of the tree diagrams, we have to start by putting a branch for each of the possibilities accompanied by its probability. Something like this. The tree diagram is a graphic representation of the possible results of the experiment, and for you to understand it better, we will apply it in an example. So, how many possible outcomes are there to flipping a coin? Well, we should know that we only have two possible outcomes. We can get heads or we can get tails. But what about the possible number of outcomes for flipping a coin twice in a row? To find the possible number of outcomes here, we are going to construct a tree diagram. Our first flip, we are either going to end up with heads or with tails. If our first flip is heads, then our second flip has two options, and again those options are heads or tails. And the same goes if our first flip lands on tails. Our second flip has two options, again either heads or tails. Now, our completed tree diagram will help us to find the exact number of possible outcomes for this scenario. Now, I'm going to talk about Laplace's law. Laplace's law is a widely used formula for calculating the probabilities of a random experiment when the events or results of the experiment have the same probability of occurring. The first thing that comes to our mind when we say Laplace's law is its formula. Its formula says probable cases between possible cases. For example, if we consider the random experiment of throwing a die in the air, the sample space would be E equal 1, 2, 3, 4, 5, and 6. And then our first event is to get an event result. So A is equal to 2, 4, and 6. Now we just have to apply it in the formula. And the result is 3 between 6.